First, you'll learn the importance of knowing your individual system. Then we'll demonstrate basic testing procedures. Now let's talk about the importance of knowing your system. In general, steam traps are designed to hold back steam and discharge condensate. The steam's energy is thus captured for use by the system. Each type of trap makes a characteristic sound under normal operating conditions. There are two major types of steam traps, intermittent and continuous flow. Intermittent traps have a normal hold, discharge, hold pattern. Continuous flow traps produce a steady, modulating sound. When you become familiar with the sounds your traps make when they're functioning normally, it will be easy to recognize abnormalities in the system with the ultraprobe. We will now demonstrate the sound of the normal functioning of 5 major types of steam traps as heard with the ultraprobe. We will also demonstrate some common steam trap failures. This demonstration will show you what sounds to listen for. However, it will still be important for you to observe your own system and recognize how it operates under different load conditions and pressures. The disc trap is an intermittent trap with a distinctive sound pattern of opening and closing. If rapid cycling occurs, the trap will fail open and waste live steam. This failure, or blow-through, has a loud, high-pitched sound. The inverted bucket, or IB trap, is an intermittent trap, and it makes a definite opening and closing sound. Sometimes the IB trap may experience continuous modulating or dribbling, especially with light loads. This may sound like a continuous flow, but it's just the normal, very rapid opening and closing of the main orifice valve. The sound of continuous condensate discharge is heard when the trap is undersized. If the trap's capacity is less than the condensate load, you'll hear the sounds of constant discharging. This situation can cause a backup of condensate into the equipment. The thermostatic trap is difficult to test because its delay in discharging can be as long as 10 minutes. Dependent upon the process load, this type of trap can be either intermittent or continuous flow. This is what it sounds like with intermittent flow. This is what it sounds like as continuous flow. The floating thermostatic trap, or F&T, is a continuous flow trap. Listen for its continuous modulating sounds. The orifice trap is a fixed orifice device. When functioning normally, its continuous flow sounds like this. To familiarize yourself with your individual system, it is helpful to first establish data for reporting purposes. We call this process of establishing data mapping and tagging. To start establishing records, break down your system into workable units. Work on one small section at a time, scheduling it into your normal maintenance routine. Create a map with a numbering system to describe each trap by type and location. Each trap is then tagged to correspond with the numbers on the map or reference file you have established. Becoming familiar with your system is a critical first step. Next, we'll discuss basic testing procedures. Before testing a trap, ask yourself if the system is stabilized. Then check if the trap is hot by using a temperature gauge or by placing your hand near, not on, the equipment. Be sure you know what type of trap you're testing and how it should sound. When you're ready to begin testing, use the ultraprobe in the contact mode. Set the frequency at 25 kilohertz and use the log position so that fluctuations will appear on the meter. Touch the downstream side to hear the condensate and possible steam sounds. If more information is needed, you may need to touch the trap body itself. Adjust the sensitivity to filter out other sounds. In a high-pressure system, you will reduce the sensitivity more than you would in a low-pressure environment where the higher sensitivity is needed. If it is difficult to distinguish between the sounds of condensate and steam, listen to a steam line. Then listen to a condensate line. If it is difficult getting to steam and condensate lines, try using the fixed band mode. It will be more sensitive to steam sounds in certain situations. The first traps we will test are intermittent traps. This is a disc trap. Listen for the disc trap's hold, discharge, hold pattern 4 to 10 times per minute. If the trap is working too rapidly, it may indicate a sizing problem. The sound of motorboating indicates wasted steam. When this trap fails, it generally fails open and a continuous rushing sound is heard. When testing an inverted bucket trap, listen for the bucket floating up and down on a bed of condensate. When this type of intermittent trap fails, it loses its prime, the bucket sinks, and a loud, continuous flow is heard. Normally, to test the IB trap, touch the downstream side. To hear additional mechanical sounds, touch the linkage. Next, we'll test continuous flow traps. The thermostatic trap can actually be either intermittent or continuous flow. It expands from the temperature of saturated steam and contracts when the temperature drops. You should determine your trap load before testing. Depending on the condensate load, there can be a continuous flow or it can be shut for a considerable length of time. On light loads, such as drips, traces, and radiator trap applications, the noise level should be relatively low. A high volume of sound will indicate a blow-by condition. In process load conditions, such as on heat exchangers, air handling coils, etc., the load will be heavy and the noise level will be high. When testing, if no sound is heard, use cold water. If it's operating properly, you will hear it open. If there is confusion in determining steam or a heavy condensate condition, use the comparison method previously described, touching steam and condensate lines. You may also check a similar trap with the same load, or you may retest at a later time when the load level is changed. It is important in testing this trap to know the condensate load of your system. Float and thermostatic traps are continuous flow and are the most difficult to test. Check this type of trap on the downstream side and listen for the modulating flow. When this type of trap fails, it usually fails closed and will be cold and silent. When testing a float and thermostatic trap, there are two conditions to consider: drip or light load and process load. On a drip or light load, a small amount of noise should be heard. If a large rushing sound is heard, it may indicate that either the main valve or the air vent has failed. If the trap is on a process such as a heat exchanger or air handling coil, reduce the condensate load by draining down ahead of the valve or by closing off the secondary flow. This could be the airflow or the water flow, and listen for a low-level sound or no sound if the trap shuts. A large rushing sound will indicate failure of the main valve or air vent. If recognizing these sounds is difficult, move the probe 12 to 18 inches and test again. The orifice trap is a continuous flow trap with a fixed orifice. Only condensate should be heard. If the trap's orifice configuration changes and steam comes through, a change in pitch occurs. When this type of trap is plugged, there is no sound. Knowing your system is critical. Whenever possible, record data when the equipment is new to establish a reference for diagnostic comparisons. How you will test each trap will be an individual decision made on location and dependent on the type of trap you will be testing. Certain adjustments may need to be made in some situations. For example, if it is too difficult to determine whether you're hearing the system's internal sounds or just the noises of a high-pressure environment, remove the contact probe from the pipe and listen. If the sound continues, it is in the environment. Reduce the ultraprobe sensitivity and use the rubber probe to block out unwanted sounds. You may also use the extender to remove yourself from the immediate area. To review, know your system. Map and tag your steam traps by type and location. Test at the downstream side using the ultraprobe in the contact mode, and make a diagnosis based on your knowledge of how the trap should sound.